Hi student, this is Professor Harmony Kim and this video is lecture week 2. Last time you studied the meaning of a sense, sensation, and perception or cognition. Upon studying cognition, let's understand the meaning of these three terminology again. Sense means a system that translates information from outside the nervous system into inside the brain into neural activity. Sensation means the process by which our sensory receptors and the nervous system receive and represent stimulus energy. So this sensation is kind of an initial message from senses. Perception or cognition means the selection, organization, and interpretation of a sensory input. So, perception or cognition is more process compared to sensation. So, perception or cognition gives some meaning to sensory input. I just told you sense, sensation, and perception or cognition. The last part of this slide says there's slight difference between perception and cognition, especially in the perspective of Buddhism. John Hale addressed the difference between perception and cognition as like perception as occurring at the lowest input level and cognition as extended at the second level, although the first level is not in the fullest sense perceptual. So our cognitive scheme requires certain steps. So initial step is referred to as perception, followed by cognition. Let's think about how many senses in the Western perspective. There are 5 senses in Western world. People think that 5 senses cover up all of human experience. What are those 5 senses? Vision, audition, olfaction, gustation, somatic sensation, touch. First, vision, the reception of light energy. Audition, hearing, the reception of a sound wave, detection of a change in air pressure. Olfaction, smelling, the reception of chemical molecules via nasal mucosa. Gustation, taste, the reception of chemical molecules via taste bud. Taste buds are located on the surface of the tongue. Somatic sensation, touch, the reception of information about pleasure, weight, temperature, movement, pain. Each sense organ has specific structure to receive external stimuli. For example, vision. In case of vision, what is the main structure for vision? Lens of the eye. Audition. Outer ear, hairs in the inner ear. More specific structure called cochlea. Cochlea looks like snail shell shape inside the inner ear. Which structure allows us to smell? Nose, nasal passage, or nasal hair. Look like a hair structure, and inside the hair, there are nerve cells which carry olfactory information to the brain. In case of taste, there are taste buds on the surface of the tongue inside the oral cavity. So inside taste bud, specific cells send a message of taste to the brain. In terms of touch, there are several cells in the dermis. Dermis is located underneath epidermis. And inside the dermis, there are several cells which sensitize pressure, heat, such as cold and hot, pain, etc. Just before we investigate the specific structure for specific sense, what about the name of specific cells which sensitize five senses? For vision, they are called photoreceptors, which are located on retina. So in the previous slide, we just studied about the specific structure which is involved to sensitize certain sensation. Now we go into a little bit more detail. Therefore, there's a specific structure, but inside the specific structure, there's a specific cells, which are the major player to sensitize and deliver message of a certain sense to the brain. In case of a vision, the name of the specific cells are called photoreceptor, which are located on retina. For hearing, audition, chemoreceptor inside hair cells send auditory information to the brain. Olfaction, for smell, chemoreceptor connect with a neuron to deliver the message of olfaction. Gustation, gustatory cells, which are specialized epithelial cells located inside the taste bud, synapse connect, synapse means connect, with sensory nerve fibers for gustation. For touch, sensory receptors for pressure and pain are called mechanoreceptor for pressure and pain, and sensory receptor for cold and hot is called thermoreceptors. You will hear about stimuli in this lecture. Stimuli means environmental energy or energy change that produce an action. For example, if I say to you, raise your hand, then you will do action by listening from me, because your cochlea inside the inner ear send the message to the brain and stimulate a specific sensory nerve cells which code for audition. How do receptors change stimuli into neural response? In other words, how physical properties of stimulus is translated into a specific pattern of neural activity. There is a process by which environmental energy, such as light for vision and air vibration for hearing, etc. Those environmental energy are translated into neural impulse. We call converting energy from one form to another transduction. So, in case of a vision, photoreceptors in the retina receive a light energy and transduce into the nerve impulse, which is referred to as transduction. Sensation means the process by which our sensory receptors and nervous system receive and represent stimulus energy. This is initial message from senses. What are the functions of a sensation? Sensation provides information about our external and internal environment. If everybody listens to the same sound except you, then your internal organ, internal hearing process has some problem. Also, sensation provide protection. So when you hear warning sound, then you will react how you respond to the urgency. Also, sensation involved in social communication. You will exchange communication by looking at email, talking by phone, or five sense organs are involved in social communication. Sensation also affect pleasure or pain. So you have emotion. I like that, I dislike that, that is too much hard work, or oh, I can manage that. Like sensation affect your emotion. Perception include selection. Look around yourself. Probably there is a light source to see your surroundings. Maybe you might turn on nice quiet jazz music while you are reading the slide. Maybe you might drink water or eating cracker, etc. Can you recognize all these activities all together at the same time? Let's think about what happened to your foot now. When you listen to the word of foot, F-O-O-T, from me, now you start to think about your foot. In other words, for your perception, you select certain sensation and organize and interpret sensory input. Before you listen to foot from me, you might not even think about foot. So it is impossible to aware all sensation occurred to you every moment. That's why perception takes place in a way of selection, organization, and interpretation, and that is the way of how perception is sensitized. Now we will study sensation, one out of five sensations, visual sensation or visual recognition. And then the rest sensation will operate similarly. We do not have enough time to cover up all five kinds of sensation and perception. But when we study visual perception, visual recognition, you can imagine that the rest sensation and perception also operate similarly. Why I choose visual recognition? Most of our impression and memories of the world are based on sight. So seeing is important, maybe more powerful than other sensations. Analysis of the visual world depends on the information coming from retina. This is the initial stage of processing. How can the external world be translated into our visual experience by way of electrical signals that are initiated in the retina and then travel through the optic nerve toward the brain? In order to understand the function, you must know the general anatomy of the structure of the eye. So you will study the structure of the eye briefly. You don't have to memorize the name of each structure of the eye, but let's look at the overall view. So light enter cornea here, the outermost surface of the eyeball, cornea, and pass through aqueous chamber. Just posterior to cornea is space, and then inside the space there's some liquid filled with this space. We call that aqueous chamber. And light continue to enter pupil, the front portion of lens. The center dark circle area is called the pupil. Outside the pupil called iris, and everybody has a little bit different color of iris. Then light pass through lens, and there's another huge chamber called vitreous chamber. And this vitreous chamber also filled with vitreous humor. Vitreous, some kinds of liquid filled in this chamber, and then eventually light get to retina. Here's the retina. The innermost layer of eyeball is called retina. Now, retina looks like a thin layer, but when you look at retina on the microscope, this retina, thin layer, when you look at retina on the microscope, you will see retina is composed of 7 kinds of different cell layers. One of the most important layers in the retina is called photoreceptor. Here's photoreceptor, this area. Retina contains millions of photoreceptors. Photoreceptors are subdivided into rod cell and cone cell. Rod cells and cone cells, they are not evenly distributed. The rod cells are most dense at the periphery. So you can see here's rod cell, the black color, and then here's periphery rod cell. So rod cells are most dense at the edge of the retina and decrease in number as the center of the retina is approached. So when you look at the center portion, you might see more cone cells. The rod cells allow us to see in gray tones in dim light. Under dark condition, these rod cells allow us to see in gray tones. So even you do not have light, you can see vaguely by help of rod cell. The cone cells allow us to see the world in color under bright light conditions. Cone cells are dense in the center of the retina. There are 3 varieties of cone cells, and each type is sensitive to particular wavelengths of visible light, such as blue, green, and red color. If someone shines red light into one of your eyes and green light into the other eye, you will see yellow. This indicates that the mixing and disinterpretation of colors occurs in the brain, not in the retina. Still, cone cells just send message of green light and red light. But your brain, human brain, mix green and red so that you see yellow color. So you need to a little bit separate what your sense organs, such as eye, do and what your brain engage in what kind of sensation or perception. Again, here's cross-section of retina. Light enter photoreceptor. So first, light entering eye triggers photochemical reaction in rod and cones on back of retina. Then, number 2, chemical reaction in turn activate bipolar cells. There are some other kinds of cells make up of retina, such as horizontal cell, amacrine cell, ganglion cell, and bipolar cell. So chemical reaction in turn activate bipolar cell. So light hit the back of retina and then reverse toward the center of eyeball. Now, information is sent to visual cortex via thalamus. Some information in relation to light is going to follow through optic nerve. Optic nerve is the region to connect eyeball to the brain. Now those messages move through optic nerve and eventually arrive at thalamus. So electrical signals pass from the photoreceptor via 2 kinds of neuronal chain. One is a bipolar cell and then ganglion cells. Information is sent to visual cortex via thalamus. Thalamus is some portion of the brain. How image can be built on the retina? When you look at the candle light, actually the image of a candle light on retina is inverted. So image built on the retina is inverted. But when you look at the candlelight, you will see the same orientation of a candlelight object. The optical image that falls on the retina is reversed by the lens, but is faithful representation of the external world. In other words, we see the same orientation of object. We are given tiny distorted upside down image in the eyes, and we perceive the world object, which is nothing short of a miracle. So when this inverted image of object on the retina pass through optic nerve, in the process that this inverted image of object is going to invert it one more time, so that your brain interpret the orientation of object as the same orientation of a real object. Let's look at the visual pathway. So here's light hit the cornea and enter until the retina, and then here's rod and cone cells on retina and send the information through optic nerve, and then now the information arrive at thalamus inside the brain, and that information continue to deliver to visual cortex, the backside of human brain. All information from the sensory organ arrives at thalamus. So inside the brain, the thalamus is the place where all kinds of sensation arrive. But only one sensation does not go into thalamus, rather directly go into frontal cortex. What is that sensation? That is smelling. So olfactory sensation does not pass through thalamus. Inside the nose, there's a nerve cell is already located inside the nasal pathway, and then that nerve cell bring message directly to cortex, just bypass thalamus. So olfactory sensation directly arrives at the frontal cortex, in which you can immediately respond to smell. Since olfactory sensation does not pass through thalamus, people usually very fast sensitize smell. That's why perfume industry can be a promising business. So here's two eyes, and here's first neuron, second neuron, and third neuron, and these neurons connect the information received by retina. So the first, second neuron connect to in retina, and then this information pass through optic nerve, and then enter the brain, eventually arrive at thalamus, and finally visual cortex. So when you look at the information processing from eye to the brain, then this optic nerve is really like a cord, C-O-R-D. And compared to the size of a retina and compared to the width of optic nerve is quite different. So in terms of retina, they carries this amount of information. Then in optic nerve, those informations is kind of squeezed, and some of them might be lost. But those information is reproduced in thalamus or visual cortex. So in retina, two-dimensional image project on the retina, but we perceive three-dimensional image of the world. The visual system transforms transient light pattern on the retina into a coherent and stable interpretation of three-dimensional world. The degree to which this process, such as from two-dimensional to three-dimensional, is creative. So visual perception is not a passive process. You actively create three-dimensional figure. The view that perception is not atomistic but holistic, which means perception involves more than just information provided by the retina. So your brain adds or creates certain figures. This view was first emphasized by Gestalt psychologists. What is the meaning of a Gestalt? I will introduce Gestalt psychologist a little bit later. So one more time, when you look at the information delivered from the retina, then those information enter the brain, and there's thalamus, and then here's visual cortex, and from the visual cortex, some information in terms of shape or color or spatial location, some attributes are delivered in different direction of the brain. So color, motion, depth, and form of the object is gonna separate it and transmit into different region inside the brain. So in terms of motion information or depth, those information goes up here, dorsal area. But color and form, this information sent to ventral pathway. This is dorsal pathway. Dorsal means up and ventral means low. So there are two streams of visual information from primary visual cortex. There are two pathways. One is where pathway, the other one is what pathway. Where pathway helps with moving and not bumping into other things. Go from the occipital lobe to the parietal lobe. Occipital lobe means visual cortex, this back of your brain. So when you touch the back of your head, that is the area for occipital lobe. Or in occipital lobe, visual cortex are located. So the light information sent by retina arrive at visual cortex in occipital lobe. Some attribute of object is gonna follow to where pathway. What kind of attribute follow where pathway? Such as moving or depth. So when you go to the department store, you saw many people, but you maneuver your behavior in order not to bump with the other person. When you see other people, then your eye sensitize other person and send this information, and this information pass through retina and then eventually arrive at visual cortex in occipital lobe, and then the movement of other person, that information is gonna send to parietal lobe. And this information makes you think that, okay, I'm gonna take this route in order not to bump with that person. Another pathway is called what pathway. It recognizes the object. So what is that object? What does that object mean to me? Okay, so what pathway just recognize the object by looking at the color, by looking at the shape and structure of the object. So what pathway goes from occipital lobe, in other words the visual cortex, to the inferior temporal lobe. So when we look at object, we think that we see one object at the same time in one pathway But that's not true. Our brain disintegrated some parameter, some attribute of the object sent to where pathway, some other attribute sent to what pathway. But these several attributes eventually merge and integrate in your frontal cortex, and then you think that you are seeing those same object at the same time. Actually, inside the brain, there is some kinds of a visual operation take place in a complex manner. So when you look at visual cortex or occipital lobe, some attribute of that object follow where pathway. Some attribute of that object, such as shape, structure, and color, those information goes to what pathway. Eye is located here, and here's back of head. Again, here's occipital lobe, and then the where pathway goes up, parietal lobe. The top of your head is called parietal lobe, and the bottom of your brain is called temporal lobe. So once visual information arrives at visual cortex, and spatial processing such as space or depth or movement, those information go up to parietal lobe. But object recognition such as shape, structure, and color of the object send to temporal region. When information go up to parietal lobe, we call that where pathway. When information of the object send to temporal region, we call that what pathway. How we can have a perception? There's two kinds of modulation take place. One is top-down modulation and bottom-up modulation. Bottom-up processing is more like sending information, visual information toward the visual cortex. Those where pathway and what pathway, those information integrated in frontal cortex. Now frontal cortex mix those information and organize and create some information. If they need more information from bottom-up processing, then top-down modulation try to receive more information from bottom-up processing. In order to send more bottom-up processing, your eyes keep looking at same object, and then information keeps sending from retina toward thalamus and visual cortex, and then from visual cortex follow where pathway and what pathway, and the information arrive from where and what pathway in frontal cortex and reinterpret, reorganize the object, and then this top-down modulation eventually allow you to have perception. So stimulus influence our perception. That is data-driven process. For example, everything looks fairly confusing, especially when you look at something new. For example, when you enter the spacecraft to go to Mars, inside the spacecraft, so many knobs and small window, computer, all these things, you might be what? Embarrassed. Those embarrassing information actually result from bottom-up processing. But your eyes seeing and send information of so many different knobs and small computer window and some index, needle, all these things. Keep sending those information through bottom-up processing. Then, top-down processing, your background knowledge to influence your perception. So, expectation-driven process. visual cortex, where pathway and what pathway, those information arrive in frontal cortex. Then bottom-up processing keeps sending visual information. Then top-down modulation receive information from bottom-up processing and think, organize, and criticize, and plan. Then, oh, I need more visual information. Then order to send more information through bottom-up processing. So, top-down modulation, bottom-up processing, they cooperate. One more time, bottom-up processing is for object recognition or situation recognition. Combine features into more complex forms, and bottom-up processing allow you to detect specific feature by looking at their shape, structure, color, and movement. Top-down processing, the main job of top-down processing is formulate hypotheses about the stimulus as a whole. Actually, you receive movement information separate, and you receive shape, structure information separately from information of color of the object. But top-down processing is interpret all these information as a whole. And then top-down processing select and examine feature to check recognition. When you look at brand new object, you do not know what that new object. Then your brain receive the structure, color, movement, or depth, all these information separately by way of a bottom-up processing. Now all those informations arrive in frontal cortex and then try to combine them as a whole and then try to examine the feature of that object and recognize, oh, this object is for remote control for TV. There are so many buttons and so many different colors on the remote control, but each button has a different function, and then you recognize that object as TV remote control. I mentioned about a Gestalt psychologist. So when you look at two-dimensional figure, people reconstruct three-dimensional image. Humans have basic tendencies to organize what they see. We see pattern without any effort rather than random arrangement. The central idea of a Gestalt psychologist is what we see represent not just the properties of the object, but more importantly, the organization of sensation by the brain. Your brain add or subtract or create some image. Therefore, the elements of the image are selectively organized by our brain to create a form that is more than simply the sum of its elements. Your retina and your visual cortex actually send intact information in terms of shape, structure, color, movement. But your brain, especially frontal cortex, organize some information selectively and then create a form that is more than simply the sum of its elements. So the brain creates three-dimensional experiences by organizing sensations into a stable pattern. We call that Gestalt. This pattern is constant despite variation on the information received. We are able to recognize different images under a variety of visual conditions because the relationships between the components of the image are maintained by the brain. Same figure, same object, but your brain create different image. So the brain creates a three-dimensional experience from two-dimensional image by organizing sensation by the brain. The brain makes certain assumptions from experience and the built-in neural wiring for vision. Look at this figure. What you can see? Can you see young lady with a hat? So here's young lady hair, and here's eyelash, and here's nose, and here's a chin, and here's ear. What about, can you see another kinds of a person, such as old woman with a scarf? So hair portions are correct, the same of a young lady. But this time, can you see this part as nose of an old woman? And here's not necklace of a young lady, instead look like mouth of old woman, and here's chin of old woman. So look at this area. The nose of old woman is the same location of chin of young lady. So maybe you might see young lady one time, but you might see old woman another time. But still same image, but your brain create differently. Let's look at figure-ground relationship. Figure-ground dichotomy. A winner-take-all perceptual strategy. So what do you see in this figure? Can you see candle stand? When you see candle stand, the background is just white board, white background. But can you see also two persons' face profile? You cannot see candle stand and two persons' face profile at the same time. Only one image you can see one at a time. So figure-ground relationship illustrated one principle of visual perception, a winner-take-all perceptual strategy. When you look at candle stand, that is black portion, then this black portion become figure, the rest part is background. When you look at white portion as a figure, then this black region become background. Like a singleness of action in motor system, in the visual system only part of an image can be selected as the focus of attention. The rest become at least momentarily background. Another example of a figure-ground relationship. So when you look at this right figure, what do you see? People can perceive a figure-ground relationship when a scene has no clear boundary between figure and background. So in this case, figure and background is not quite clear. Then people put imagination. We call that illusory contour. So kinds of subjectively, you imagine and create certain image. Our category of a visual illusion is known as illusory contour. You might see triangle in this figure as well as reverse triangle also. Humans perceive scenes more accurately if we fill in the blank. Here, in this blank region, you feel something. Then you create reverse triangle. In case of illusory contour, This rational strategy leads to a perceptual error. There is no reverse triangle. Do you agree? But you think that, most people think that there is a reverse triangle. That is mistake, that is error. So, Gestalt psychologists were intrigued by ambiguous figure-ground relationships and illusory contours. Human perception is more than the sum of information in the distal stimulus. These are the only stimulus. This incomplete circle and some part of line, these are the intact object. But human perception is more than the sum of information in the distal stimulus. When you study perception or cognition in the Buddhist perspective, the Buddha addressed illusion as one of affliction. Because of illusion, people are suffered. Maybe humans are already designed to have illusion in the context of a figure-ground relationship. Now you know about this, and then how you really awaken, how you really aware, oh, what I'm seeing is not real object. My subjective imagination is already involved. Maybe my subjective involvement might cause suffering. We will get there when we study Buddhist perspective of perception or cognition. So, see edges, although not physically present in the stimulus. Inverted white triangle, which is brighter than any other part of a stimulus. These are all examples of illusory contour. So illusion illustrate how the brain applies certain assumptions about the visual world to the sensory information it receives. So illusion misreading of visual information by the brain. Illusion can be subcategorized. One is Muller-Lyer illusion and moral-induced illusion. So this is Muller-Lyer illusion. Two lines you see. Actually, the lengths of two lines are same. But you think that two lines of equal length looks unequal. Knowing that the lines are equal does not prevent us from being fooled by this illusion time and again. Humans perceive the lines to be unequal because the brain uses arrowhead, this part, this arrowhead, as an indicator of size. But when you look at all in line, the lengths of a line are exactly same. How you see phenomena with right view is important, which the Buddha stressed. Right view, right view. Humans fail to aware visual objects. Failure of visual awareness means fail to notice something that is clearly visible once we know to look for it. This is related to overactive top-down processing. Do you remember top-down processing? They collect all information coming from bottom-up processing and then make them holistic and create three-dimensional image. In the process of top-down modulation, humans fail to notice something that is clearly visible. So failure of visual awareness resulted from overactive top-down processing. There are two categories of failure of visual awareness. One is changing blindness and the other inattentional blindness. Changing blindness is failure to notice an obvious change. There's a change occur, but humans cannot catch the change. Inattentional blindness means failure to notice the existence of an unexpected item. In the middle of a situation, some unexpected things happen. Then humans fail to pay attention to that unexpected happening. So let's go into change blindness first. Large change with a visual scene are undetected by the viewer typically when there has been some visual disruption such as an eye movement or a brief flicker screen. Top-down processing encourages us to assume that the basic meaning of the scene will remain stable. So human brain sometimes lazy to adapt changing situation. Do not store a detailed representation of a scene. Let's look at the example of changing blindness. And when you look at the bottom part of this slide, you can see web address. Please make copy and paste in new browser and you can watch short video of change blindness. I tried to upload this bite-sized video in this lecture, but it is against the law. So you just copy the web address and paste in new browser and you can watch very short size of changing blindness video. So as you see the video, changing blindness take place when humans do not store a detailed representation of a scene. What about inattentional blindness? If you do not pay attention, human can miss perceiving some very obvious things. People experience inattentional blindness when the primary task is cognitively demanding more than other tasks. People often fail to notice a new object if they are paying close attention to something else. So let's watch another video in relation to inattentional blindness. Again, you copy web address in this slide and paste in new browser and you can watch short video of inattentional blindness. You watch two kinds of video and this slide explains the difference between changing blindness and inattentional blindness. You can read through. And one more category of illusion is motion-induced illusion in normal observers. When a global moving pattern is superimposed on high-contrast stationary or slowly moving stimuli, the latter disappear and reappear alternately for a period of several seconds. This is similar to that found in clinical cases of attention deficit, in which partial invisibility might occur despite the primary visual areas being intact. Disappearance might reflect a disruption of attentional processing, which shifts the system into a winner-take-all mode, uncovering the dynamic competition between object representations within the human visual system. Let's do some experiment. Again, you copy and paste web address on the bottom of this slide and please do experiment. Try to look at the center. At the same time, count the number of yellow dots while the panel keeps moving. Can you constantly see 3 yellow dots? Some students might see 2 dots, sometimes even 1 dot. That is extremely normal. If someone continuously sees through yellow dot, that is exceptionally rare case. But 3 yellow dots present all the time. Your brain manipulates visual situation. So from the perspective of neuroscience, human perception includes lots of error due to illusion, and most humans might not even recognize or admit this illusion. That might be the reason why humans have difficulty in escaping from suffering. Next week, we will study the Buddhist perspective of perception or cognition, which has different system and different interpretation compared to the Western world. Quiz 1. Which of the following is the sensory receptor for the vision? You can find the answer from the previous slide. What is it called when people fail to notice a change in some part of a stimulus? What is that? Changing blindness or inattentional blindness? For visual perception, top-down and bottom-up processing take place. Which pathway provides selection and recognition? You can find the answer from the video. So you have to submit assignment week 2. So this is the format what you submit week 2 quiz. My email address, include your email address on CC and subject title Board 420 week 2 quiz, week 2 assignment, or just week 2 is okay. In the text body of email, you have to write down your official name first. Last name, comma, followed by first name. This is important. Without your official name, you cannot get attendance point. Your submission will not be counted. So before writing the answer of 3 quiz, writing your official name must be preceded. So write down your official name, last name, comma, follow the first name, then write down the answer of a quiz. Quiz 1, answer maybe 1 of ABCD, quiz 2, quiz 3. And the due of submitting week 2 assignment is next Sunday until midnight. So this is the end of week 2 lecture.